Okay, now we're doing section 3.6 and number 65, and we're going to use the chain rule. And before we start, I've got an identity here, and if y equals the derivative, or excuse me, the square root of f of x, and y prime, and we've developed this in class, equals, we stick that in the square root in the denominator, double it, and then we go upstairs, and in the numerator we install the derivative of f of x, which is f prime of x, and that's by the chain rule. So let's go ahead and do that. So y prime equals, and we know this, we're going to have a 2 and the square root of 1 plus cosine of t squared. And then we're going to take the derivative by the chain rule of 1 plus cosine of t squared. Well, the derivative of 0 is 0. The derivative of cosine of t squared, the first thing we have to do, we work from the outside in, so we'll take the derivative of cosine, which is negative sine of, and that's t squared. Then we go in and we take the derivative of t squared, which is 2t. So let's consolidate what we can, and notice these common factors in the numerator and denominator, so those 2's will divide out. So upstairs we have a negative t sine of t squared, and downstairs we have the square root of 1 plus cosine of t squared, and we're done. Okay, now we're doing question 99, and keep in mind that the velocity equals the first derivative of the distance, or the position. The acceleration equals the second derivative of that, and we're letting t equal 6 seconds, and the position is described by s equals the square root of 1 plus 4t. So and we have to find both the velocity and the acceleration when t is 6 seconds. So let's find the velocity. So taking the first derivative of this, we know we have a 2 here, the square root of 1 plus 4t. And by the way, we're talking meters and seconds. And then we go inside and we take the derivative of 1 plus 4t by the chain rule, and we get a 4 there, and 2 goes into 4 twice. So the velocity when relative to 6 seconds is going to be 2 over the square root of 1 plus, and replacing t with a 6. 4 times 6 is 24. So we've got the square root of 25, which is 5, so that equals 2/5, and that's going to be meters per second. Now, let's find the acceleration, and we'll do that over here. And so a equals, and now we're taking the derivative of the velocity, so we'll use the quotient rule, and we square the denominator, and we get 1 plus 4t. And then we take the derivative of the numerator, which is 0, multiply it times whatever quantity's in the denominator, so we still get 0. Then negative sign, we hold the 2 constant, we take the derivative of 1 square root of 1 plus 4t, which is, we've already computed that, 2 over the square root of 1 plus 4t. Now, this equals negative 2 times 2 is negative 4, and over, and when we invert and multiply and simplify, we'll have a 1 plus 4t to the 3/2. And so a of 6, letting t equal 6, we get negative 4 over 25 to the 3/2. Well, the square root of, so there's negative 4. And by the way, these should be meters per second squared. Negative 4, and when you take the square root of 25, you get 5, and when you cube 5, you get 125. So that's going to be meters per second squared, and we're done. Yes.